Hello everyone, I am R.Malathy from the Department of Mathematics, SNS College of Engineering. In the lecture series, this is the last chapter from the first unit, that is Introduction to Probability Distribution. Um, in this we are going to see the binomial and Poisson and exponential. Binomial already we have discussed. Probability distribution or mathematical function that provides probabilities of occurrence of different possible outcomes in an event. They are essential for understanding the analysis of events, random events. So in binomial distribution already we have discussed when we can go for the binomial distribution. That meaning is we have to go when we are talking about success and failure of an experiment, that time we have to go for a binomial distribution. In this chapter we are going to see Poisson distribution and geometric distribution. First, Poisson distribution is Poisson experiment gives numerical values of random variables x which represent the number of outcomes occurring during a given time interval or in a specific region. It is also called as counting random variables. Definition is the probability distribution of Poisson random variables x representing the number of outcomes occurring in a given time interval or specified region represented as t is a probability of x equal to x e power minus lambda t into lambda t power x by x factorial. X starts from 0 to infinity. So this is also comes under discrete but infinite countable terms we are having. Here lambda is the variable of outcomes per unit times or region. Properties of Poisson variable is the number of outcomes occurring during a time interval is dependent of number of that occurs in any other disjoint time interval. So it may memoryless. The probability that a single outcome will occur during a very short time interval is proportional to the length of the time interval. It does not depend on the other number of outcomes that occurs outside this time interval. The probability that more than one outcome will occur in such a short time, the interval is negligible. So here also we have to talk about moments. The four moments we are having that is mean, variance, skewness, kurtosis. That all we have to talk about here also. The overview of Poisson distribution is we have discussed about definition and that we have to know about characteristic. It is used to model the number of event in a fixed interval of time or shape, such as the number of incoming calls at a call center in a minute. So at a time, if you are having more than one response, means we have to go for the Poisson distribution. For that only I have given here the example of call center. At a time we may have more than one call or two call, so that we have to go for the Poisson distribution. Application is commonly used in business, telecommunication, reliability engineering to model various type of discrete events. Then characteristics of definition characteristic of Poisson distribution is the Poisson distribution is defined by the rate at which events occur at the end of probability observing a given number of events with a fixed interval of time or space. Characteristic is it is characterized by the fact the event occurrence are independent of one another and the average rate of occurrence is constant. Application of Poisson distribution is in data analytic field, in quality control, in risk management. We are using Poisson distribution in data analysis used in fields such as biology, economic, environmental studies, for analyzing rare events and occurrence. In quality control applied to monitor defects and faults if we want to check the defects and if we want to check the faults in the manufacturing process and to control the quality products. If we want to produce a good product, we should check their Poisson distribution. We have to use their Poisson distribution. In risk management also, ensure and finance to assess risk and predict the likelihood of rare adverse event. In technical terms, in Python we are having a package called NumPy. In this we are having many packages. We can use dot mean, dot variance, dot Poisson distribution, and dot binomial distribution. So we are having many packages in Python also. So if you want to go for a data analytics, data scientist, data analytics, we should know what is binomial, what is Poisson, what is geometric distribution, what is gamma distribution, what is normal distribution. We should know the distribution for predict the future, for predict the what disease is this, for finding the fault, for finding the defect in the products. So we should know the distributions. Visualizing the representation of distribution as probability of event. Visual representation discipline the probability of different number of events occurring with the fixed intervals. Intensity of occurrence. Graphical representation showing the intensity of event occurrence related to the time or space interval. Overview of geometry distribution is the geometry distribution models the number of trials needed to achieve the first success. So if you are talking about the first success in repeated independent Bernoulli's trials, so geometric distribution is nothing but based on Bernoulli's trials. So if you are tossing a coin 10 times, if you are tossing a coin 100 times, means we have to go for the binomial distribution. For example, if I am saying, if I cleared 10th standard board now, why I have to again write this 10th standard board? So once I have received the success, again we need not to do the same trial. So in that case we have to go for the geometrical distribution. This characteristic is used to analyze the probability of success or failure in problems with a fixed probability of success on each trial. Definition and characteristics of geometric distribution is: the geometric distribution is defined by a probability P representing the probability of success in each individual trial. The characteristic is by the fact that trials are independent and have a constant probability of success. Visual representation of geometric distribution is two trials needed. Visual illustration showing the number of trials needed to achieve the first success in a series of independent trials. Success probability is graphical representation illustrating the probability of success in each individual trial. Thank you.